In this chapter, we're gonna discuss about applications of integration. It's gonna be about the area and the volume that we're gonna discuss, and it's gonna be about the arc length. So it's gonna be consist of the area that I'm gonna cover in this video, and we're gonna have a long lecture on the volume. It's gonna be consist of 3 techniques. It's gonna be about the cross section, the disk method, and the cylindrical shell. And you're gonna have the arc length at the end for another video. So first of all, let's discuss about the area between two curves. So you see that you have the interval AB here, and you have your y equal to fx and y equal to gx. And you would want to compute the area between these two curves. Okay, so you want to compute this area. So the concept will be just you're gonna divide the interval AB into small pieces, and you will use the Riemann sum. So you see that if you divide the interval AB into small pieces like this one, and you're gonna find the area of the rectangle, the height of your rectangle turned out to be, you see here that it's gonna give you the area of the rectangle. And if you recall the Riemann sum, so it's gonna be the sum of the height and multiplied by the width, which gonna turn out to be dx. So it's gonna be, I just gonna say HIGHT, the height, multiplied with delta x. And the height that you have in this case turned out to be the function fx minus gx. So you see that your highest point is your fx and your lowest point is your gx. So it's going to turn out to be the height here will be equal to fx minus gx. And you're going to multiply with delta x. Okay. And for this guy, it's going to be just this Riemann sum. And you see that this guy convert to, okay, so this guy convert to integral from a to b of fx minus gx dx. Okay, so this one will be just the top function. So I'm gonna say that the top function subtract by the bottom function. Okay, so if you have the function y equal to fx and y equal to gx, and you would want to find the area between these two curves, it's going to be just the top subtract by the bottom, and you're going to integrate from a to b. So you have the area of S turned out to be integral from a to b of fx minus integral from a to b of gx. Okay, so this one you can compute it this way, or you can just integrate term by term. So it's going to be integral of fx minus integral of gx. Okay, so this one will be the area. So let's do the first example. The first one asks you to find the area enclosed by y equal to e to the x and y equal to 1 over x over the interval 1 to e. So for this guy, you see that it's gonna be this one. Y equal to e to the x has the graph like an exponential function, so it's gonna be something like this. Okay, and you have y equal to 1 over x, which gonna give you a hyperbola that's gonna tend to 0 as x go to infinity. So for this guy, it's going to be y equal to 1 over x. And for this one, it's going to be y equal to e to the x. Okay, and you see the intersection point here. We don't know about it yet, but I'm gonna just try to plug in. So when x equal to 1, okay, when x equal to 1, this guy is going to be 1. And this guy is going to be E, and E is about 2.718. So you see that the point that we're gonna have is turned out to be here. So this one will be your graph for x equal to 1. So you see that the orange guy is higher than the green one. And you're gonna have E. So the next one is gonna be E. So you're gonna see that it's gonna be about here. Okay, so this one will be your E. So you see this graph turned out to be this area that you're looking for. Okay, so you're gonna integrate. Okay, so you're gonna integrate for the area. So the area that you're looking for turned out to be integral from 1 to E. Okay, so you know that's gonna be from 1 to E. And you're gonna have the top guy, which is E to the X, subtract by the bottom one, which turned out to be 1 over X. And you have dx. Okay, so it's going to be integral from 1 to e of e to the x minus 1 over x dx. And you're gonna integrate. So you integrate e to the x, so it's going to be e to the x. Integrate 1 over x, so it's going to be log absolute x. Okay, so it's going to be from 1 to e. And this guy turned out to be e to the e minus log e. And you have e to the first minus log 1. Okay, and you have your final answer. So e to the e is e to the e, nothing can simplify, and log e equal to 1. I don't need to put absolute value because e is positive. So put absolute or not putting absolute turn out to be the same answer. So this guy is going to be 1. And you have e to the first equal to e and log 1 equal to 0. Okay, so this will be giving you the final answer for this area. Okay, so you see that it's kind of easy to compute the area. However, you have to know which one going to be top, which one going to be the bottom. So you need to compare the value of the function. The higher one turned out to be the one that on top, and the lower one turned out to be the bottom one. Okay, the next thing that make this topic difficult turned out to be you need to be able to graph the function. So you like to find the area enclosed by y equal to 2x minus 1 and y equal to x squared minus 4. Okay, so you have to recall that this one will give you line, and y equal to x squared minus 4 will give you a parabola. Okay, so you have a line and a parabola. And in order to graph a line, so you're gonna need like 2 points. In this case, normally we're gonna use just x-intercept and y-intercept. So when x equal to 0, you get y equal to negative 1. And when you have y equal to 0, you solve for x, you get x equal to 1/2. Okay, and for this parabola, you're going to begin with y equal to x squared, and the factor negative 4 here will move your graph down 4 units. Okay, so this will factor the graph down 4 units. Okay, so in this one, you're gonna have the parabola. You're gonna have the parabola y equal to x squared minus 4. And you're gonna have, so in this case, you have y equal to 2x minus 1. So you have x equal to 0, y equal to negative 1. So y equal to negative 1 and x equal to 1/2. Okay, so this one will give you the line. Okay, so this one will give you the line y equal to 2x minus 1. Okay, And the next one will be your parabola. So before I graph the parabola, let's us find the intersection point. So the thing that important in the graph also is going to be the intersection point. The intersection points that we're gonna find is gonna just try to solve for xy simultaneously for the system of equation y equal to 2x minus 1 and y equal to x squared minus 4. So this is your first equation. This is your second equation. And you see that you have 2x minus 1 equal to x squared minus 4. So you solve, you get x squared minus 2x minus 3 equal to 0. That allows you to factor into x minus 3, x plus 1 equal to 0. So you get x equal to 3 and negative 1. Okay, so you know that you need 3 and negative 1. This is 1/2, right? So it's going to be 3 and negative 1. Okay, so that my 3 and negative 1. And you're going to have y equal to, okay, so you're going to plug in to this equation. So you would get y equal to 5, okay, and negative 1 is going to be negative 3. Okay, so this one is going to be, you know that it's going to come down 4 units. So this is 1, 2, 3, and 4. Okay, and you're going to need your parabola that intersect 3 and negative, that is going to be 3 and negative 1. That will be your intersection point. However, you also know that this guy has x-intercept at 2 and negative 2. Okay, so let me put that down also. So we're gonna get the nicer graph. So you have x-intercept at 2 and negative 2. Okay, so you're gonna have x-intercept at 2 and negative 2. So in this case, you're gonna have 2 and negative 2 here, and you have, I think my negative 1 kind of far, that far, I think. Okay, it's not gonna be balanced. Let's erase this guy a little bit. Okay, so this one will be 1, 2, and this one will be your parabola. Okay, and you're gonna have this one going up and intersection at 3. Yeah, it's correct. So you have this intersection point, okay, and this guy will be 3 and 5, okay, and this guy will be 1 and negative 3. I'm sorry that my 5 seems very low, okay, so in this case 3 and 5. So you get this. I'm gonna shade the area, so we're gonna have this area for the region that we're gonna find the area, the area. So this guy is in math, we call this thing region. Okay, so it's gonna be the region that we're gonna compute the area. So you see that we're gonna integrate from x equal to negative 1 to x equal to 3 in order to cover all the region. So we will integrate from x equal to negative 1 to x equal to 3 in order to cover the region. Okay, so the area that we gonna have turn out to be integrate from -1 to 3, okay? And you see that the top function is 2x minus 1, so you're gonna put 2x minus 1, okay? So it's gonna be the higher function. Subtract by the bottom one, you subtract by the bottom one, which is the blue one. So in this case, the bottom guy is y equal to x squared minus 4. So it's gonna be x squared minus 4, and you have dx. So you're gonna just integrate. So you integrate this guy. So you integrate 2x minus 1, so it's going to be 2x squared over 2 minus x minus x cubed over 3 plus 4x from -1 to 3, okay, from -1 to 3, and you're gonna just plug in. So you have x squared minus x, okay, minus x cubed. So I'm gonna combine the similar term. So this one and 4x will combine together. So it's gonna be x squared plus 3x, okay? And you're gonna get the last guy, which is x cubed over 3, and this guy is from x equal to -1 to x equal to 3. And then you're gonna just have 3 square plus 3 times 3, okay, minus 3 cube over 3. Okay, so that's the first one. The second one, you're gonna get -1 square plus 3 times -1, and you have minus -1 cube over 3. And you see that these two guys disappear. Okay, so these two guys disappear because it's gonna be just 9 subtract 9. Okay, and you see that this one will be 27. Let me write down 27. Okay, and you have -1. Okay, so you have -1, and you gonna get what? You gonna get +3. Right, so it's gonna be +3. Okay, and you gonna get minus of. Okay, you gonna get minus. So because this one is turned out to be -1/3. Okay, so this is how we have. So this would give you 29. Okay, so this would give you 29 and -1/3. Okay, so it's gonna be, how much do I have? I have 57, right? I have 57, so it's gonna be 56/3 for my final answer. Okay, so this is how we have this one for the solution. 3x positive. Yeah, it's correct. So you see, the important thing that I like to emphasize is going to be when you like to find the area of the region enclosed by two curves, sometimes you may need to be able to sketch, and the way to sketch is going to be just like maybe parabola, or the thing that you have to be able to find will be also the intersection point. The next one, you're gonna find the area enclosed by x equal to y squared minus 4y. This one will give you parabola, and this one will be your parabola. And we know that we have y positive here, so we have the quadratic term positive, so it's gonna be open to the right. And the second one is going to be y equal to, not y equal to x equal to 2y minus y squared. So this one is parabola. Okay, and this guy is open to the left. Okay, so it's going to be open to the right and open to the left. So for this one, you see that x equal to y squared minus 4y will be this parabola that opening to the right. Okay, let me try to draw this one like this. It's not nice. Let Okay, and you have y equal to this guy. Okay, so this one is x equal to y squared minus 4y. Okay, and you have another one which is x equal to 2y minus y squared. Okay, so that will be another guy. And you see that if you like to know which one is going to be higher and lower, so the thing that you see is going to be the region that we will find the area turned out to be the yellow region here that enclosed by these two curves. Okay, and you see that it's gonna be this one and the intersection point. So you need to find the intersection point. So it's gonna be at here, and let me use. So it's gonna be here, and it's gonna be at the origin. Okay, so you have it's gonna be the intersection point at the origin, and it's gonna be at negative 3, 3. Okay. And you see that if you like to integrate, so you're gonna see that if you divide in this direction, so if you divide something like this, you see that you're gonna have fx, gx differently. So you see your fx, gx, fx, gx, and fx, gx. So it's gonna be changing all the time. So we're not gonna choose to divide in terms of x. So if you divide in this direction, so you see that your curve on top and your curve on the bottom turn out to be changing. However, if you divide in this way and you find the curve and the rectangle area, okay, so if you divide in this way, you see that it's going to be this guy to the purple one, okay, and you see that this one in math, this guy is on the negative side, and this one is on the positive side. Okay, so if you see you're gonna integrate from 0 to 3 and the area of the rectangle that you get will be this rectangle. So this one will be the picture that I gonna draw. Okay, so it's gonna be you're gonna integrate. We will integrate with respect to y. Okay, so it's going to be with respect to y, and it's going to be from y equal to 0 to y equal to 3. Okay, so we're going to integrate with respect to y, and it's going to be from y equal to 0 to y equal to 3. And you're gonna have the area. Okay, so you're gonna have the area, so it's gonna be integrate from 0 up to 3. Okay, and you see that you need, it's not going to be the top subtract by the bottom, so this guy will be the positive subtract by the negative. Okay, or sometime I will call this guy is going to be right. Okay, on the right side subtract by the left side. Okay, so that will be the thing that you have to concern. And here you see that it's going to be dy, not dx. And then you're going to set it up. So it's going to be integral from 0 to 3. And the right one turned out to be the orange one. And the green one turned out to be, the right one is the green one. And the left one turned out to be the orange one. So for this one, so you're going to begin by putting the green one. So it's going to be 2y minus y squared. And you subtract by the orange one, which is y squared minus 4y dy. Okay. And you're gonna just combine this one first. So you see that it's going to be 6y minus y squared, and you integrate from 0 to 3 dy. So you integrate 6y, so you get 6y over 2 minus y cubed over 3 from 0 to 3. So you get 3 squared minus 3 cubed over 3, subtract by 0. Okay, and this one will be 27. Okay, and you integrate y square. Okay, so you integrate y square. Sorry, I think I forgot 2. Okay, so it's 2y square. Let me fix this one. So it would give you 2 3 cubed over 3. Okay, and so you get 27 subtract by 18. It will be 9. Okay, so this one will give you the final answer equal to 9 in this case. Okay, so this one will be just the area that you have to integrate with respect to y. Why did we integrate with respect to y? It is because if you integrate like this, that you have vertical rectangle, you see that your graph is changing. So the top and the bottom always changing. However, if you divide by using the horizontal rectangle, the graph turn out to be the green one subtract by the purple one. Okay, so that would be easier, and it's going to be just one piece. Okay, now we're gonna concern on this picture. So we write the definite integral for the area of the region enclosed by 3 graphs. So you have x, y equal to 2, y equal to x plus 1, and 11, x minus 2y equal to 43. So you see that we're gonna first identify the intersection point for this graph. Okay, so we're gonna first find the intersection point. So you see that this one will be your intersection point, and the intersection point. Okay, so you see that it's gonna be this one is gonna be 5. Okay, and 6. Okay, the second one is 4 and 0.5. Okay, and for this one it's gonna be 1 and 2. Okay, so this one will be just these 3 intersection point, and we're gonna try to find this one, 2, like this. Okay, so it's gonna be like this, and you see that Okay, so and you see that it's gonna be 1 to 4. So it's gonna be you need to like divide the picture into two pieces. You have one. Okay, so you have one and you have two. So for this one and these two pieces, okay, so you're gonna have number one and number two, and why did I do that? Because when I draw the rectangle, I see that the top function is x plus 1 and the bottom function is the hyperbola xy equal to 2. But after this one, in this interval, you see that the top function is x plus 1, but the bottom function turned out to be the straight line 11 minus 2y equal to 43. So this one is going to be, you need to integrate two pieces instead of one. Okay, so for this one, I gonna integrate. Okay, so the thing that I gonna integrate turned out to be the area turned out to be 1 plus 2. Okay, and it's going to be intricate. You see that for number one, it will cover from 1 to 4. Okay, so it will cover from 1 to 4. And the second one is will cover from 4 to 5. Okay, so it's gonna cover from 4 to 5. So in this case, it's gonna be integral from 1 to 4, and you have the top guy, which is I'm gonna integrate. Let me put color for you first. So it's gonna be this rectangle. Okay, so it's indicate this rectangle dx plus you're gonna integrate the second one, which is integral from 4 to 5, and you're gonna integrate the green rectangle. Okay, and it's gonna be the green one. Okay, and you have your dx. And now you're gonna write down what will be this rectangle. So it's gonna be the top one, which is x plus 1. The bottom one here, you're gonna solve for y first. So for this one, you see that this one is y equal to 2 over x. Okay, so for this guy, it's gonna be x plus 1 minus 2 over x. Okay, so that my first rectangle, so it's gonna be 1 to 4, and you have dx. Okay, and for the second one, you're gonna integrate from 4 to 5 of the green rectangle. So again, you solve for y. So you get y equal to, I believe, 11x minus 43 over 2. Okay, so it's going to be 11x minus 43 over 2. Yeah. So you get x plus 1. So you have x plus 1 is on top minus 11x minus 43 over 2. Okay, and you have dx. Okay, and for this one, it's going to be this 2 integral. The last one, okay, so the last thing that I like to mention will be, you may do the integral by like using dy also for this picture. Okay, so let me do this one with dy for you a little bit. So for this one, Let me take the screenshot. So I'm gonna have my new picture here. Let me explain it here. So you see that you're gonna be able to use horizontal rectangle also. So if you use horizontal rectangle, so you're gonna see that I'm gonna have the pink one here, and I'm gonna have the red one. Okay, like this. And you see that, okay, you're gonna have this guy and this guy, and you see that it's turned out to be the middle one. Okay, so it's turned out to be the middle one, and it's turned out to be this point, like I told you, it's going to be at 1, 2. This one will be 5, 6, and this one will be 4 and 0 0.5. And you see that for this one, how would I know that it's gonna changing? It's because you see that this guy gonna be this right to left, okay, and this one is right here, and it's gonna be left here. So the curve is changing, and it's changing at y equal to 2. Okay, so the curve is changing at y equal to 2. So you will have number 1 and number 2, same as before. Let me write down number 1, okay, and number 2. Yeah. So you're gonna integrate, okay, so you're gonna find the area equal to integrate number 1 plus number 2. And number 1 will be integrate from 2 to 6 of the red one dy, and you have integrate from 0 to not 0 0.5 to 2 of the pink one, okay, and dy. Okay, so this one is how we obtain the area. And do what? And you're gonna see that the 2 to 6 and the red guy turn out to be, you need to solve for x equal to, so it's going to be x equal to 2 over y, and this guy is x equal to 43, so it's going to be 2y plus 43 over 11. Okay, so for this one, it's going to be, why do we need to solve for x? We need to solve for x is because when you are integrating with respect to y, you need the curve in terms of y. So in order to get the curve in terms of y, it's going to be, you need to solve for x equal to, and you would get something in terms of y in order to plug in for your function. For the right function, you have 2y plus 43 over 11. And for the left function, you get 2 over y. So I'm going to plug them in. So it's going to be 2y plus 43 over 11 minus 2 over y. And you have dy plus integrate 0 0.5 to 2. And you have the pink one. So you get 2y plus 43 over 11 minus, okay, the function here is going to be x equal to y minus 1. Okay, and you have dy. Okay, so that's all I have. Okay, so this cover all of the topic about the area that we have. The area will be the first idea for doing the volume. The volume turned out to be just the area multiplied the height. So try to understand how we obtain the area by the integration, and you will use this idea in order to find the volume in the next section. Okay, so I'm gonna stop here and we're gonna continue with the volume next time.